Hey fifth graders, it's Mrs. Trombley. It's time for lesson 3 in your chapter 5 packet, your unit 5 packet. And today we're going to look at how to multiply decimals by whole numbers. To start off, we're going to review a blast from the past, what multiplication means. And when you first learned how to multiply way back when, you learned that multiplication was really repeated addition. So instead of saying 4 plus 4, yes, write this, plus 4 plus 4 plus 4 plus 4, you could say 1, 2, 3, 4, 5, 6 times 4 because you have 4 that you are adding 6 times, right? And we learned our little count by songs to be able to do that. And 4, 8, 12, 16, 20, 24. Then you added a little bit more to the mix and you learned about the commutative property. So you learned that 6 4s is the same as 4 6s. So you learned that you could also add the number 6 4 times, and that would mean the same thing as 4 times 6, or 6 times 4, and 6, 12, 18, 24. Well, we're going to use this repeated addition to help us develop a pattern to be able to multiply a whole number and a decimal. So I will tell you right up front, we're not going to use repeated addition when we're doing all of our answers. We're going to use repeated addition to help us develop the pattern. And then once you understand that pattern, then you'll be able to do kind of what I would call like the shortcut or the standard algorithm way. But I don't want you just to try to memorize a way. I want you to understand it because there's too many things in math you'd have to memorize if you didn't understand them. So I have 4 times 6 tenths, right? And up here we said I could either say I have 6 4 times or 4 6 times. With this one, it'd be kind of hard to like show the repeated like 4 6 tenths of a time. So we're going to show 6 tenths 4 times because of the commutative property. So this is the same thing as saying 0.6 or 6 tenths added 4 times, right? That's kind of like what we did up here, except we have 6 tenths. Now we already know that when you add 6 4 times, you get 24. So I'm going to bring down my 4 and carry my 2. And 2 added to all those zeros is just 2, and we're going to build a taller snowman this time. So we end up getting a product of 2 and 4 tenths. So 4 times 6 tenths is 2 and 4 tenths. Let's do the same thing for this one. I'm going to look at this as 6 hundredths 4 times. So I'm going to go ahead and add 6 hundredths 4 times. You should too. All right, when you add this, we know we get 24, so I'm going to carry my 2. And when I add 2 plus all those zeros, it's 2. And again, I have my nice tall snowman and a 0 in the ones place. So if you have 6 hundredths 4 times, you end up having 24 hundredths. And the last but not least example, I have 6 thousandths 4 times. Can you take a guess at what that's going to be? Okay, let's see if you're right. I wish I could hear you. I can't. Hopefully your guess was right. If not, it's no biggie. I think by the end of this, you'll be just fine. So when you add up 6 thousandths 4 times, we know that 6 4 times is 24. And I'm going to bring down this 0 because when you add a bunch of zeros, you get to nothing. There, I need my decimal points lined up, and there's my 0. So if you guessed 24 thousandths, you are correct. Okay, now we're going to take a look at this and see if we can come up with a pattern here. First off, I guess trying to lead you to this pattern, how do you get your digits? Like, where does this 24 come from? And I hope that you're just noticing, oh, it's 4 times 6, 4 times 6, 4 times 6. So it appears that to get the digits, all you have to do is just multiply the numbers, right? Okay, now what about the decimal point? Like in this one, there's 1 digit to the right of the decimal point. In this one, there's 2 digits to the right of the decimal point. And in this one, there's 3 digits to the right of the decimal point. What pattern do you see? What I'm hoping that you notice, and in class, we would be able to talk through all of this, of course. I'm hoping that you see, oh, in my problem here, this decimal factor has 1 digit to the right of the decimal point, and so does my product. And in this one, my decimal factor, factors are numbers we multiply, has 2 digits to the right, and so does my product. And in this one, my decimal factor has 3 digits to the right of the decimal, and so does my product. That happens every single time. When you multiply a decimal by a whole number, which is what we're doing here, the product has the same number of decimal places as the decimal factor. So this would be the decimal factor. My decimal product is 2.4. There's one digit to the right of the decimal point. In my decimal factor, there's one digit to the right of the decimal point. So if we had to come up with kind of like a standard way to do this when you're multiplying a whole number by a decimal point, I guess the first thing that you would do is ignore the decimal point and just multiply the digits. Meaning, when I see this, 4 is fine, but here's my decimal factor. If that decimal point wasn't there, I'd have 0.6, which is the same as 6. So step 1, you ignore the decimal point and just multiply the factors, 4 times 6. So down here for step 1, we're going to say, ignore the decimal, semicolon, multiply the digits. Right? And every single one of those, our digits are 24, and 6 times 4 is 24. Now, to try to figure out where do we put that decimal point, remember that the decimal point goes basically in the same number of digits to the right of the decimal point in your decimal factor. Your answer should have the same. So all you have to do is you count the number of digits to the right of the decimal factor. You say hashtag, I say number. Count the number of digits to the right of the decimal factor. Remember, factors are numbers you multiply together, so the decimal factor is going to be the number that you're multiplying that has a decimal in it. And then your product, your answer, but we're going to use product because that's the fancy math way to say it. Your product, the answer to the multiplication problem, will have the same number of digits to the right of the decimal. Okay, so if you need to, you can pause this to finish writing. I'm going to jump back up here, so press pause if you're not done and press play when you're ready. So if we use this process here, I see 4 times 6/100. I would just ignore that decimal point, and if that decimal point wasn't there, I would have 0.006, which is equal to 6. So I would do 4 times 6 is 24. And then I would look at my problem and see, oh, there's 2 digits behind the decimal point here. So I need 2 digits to the right of the decimal point in my answer. That's it. Those two match, right? Because if you have 0 ones here, you'd have 0 ones. You're good. Same thing here. If this decimal point wasn't there, I'd have 0.006, which is the same as 6. So I would do 4 times 6 is 24. And there's 3 digits to the right of the decimal point in my decimal factor. And I need 3 digits to the right of the decimal point in my decimal factor. So here's 1, 2. I need to put a 0 in there so that I can have 1, 2, 3 digits to the right. Notice I didn't put one after because I'm counting, I want 3 digits to the right, and if I put a 0 after here, I'm making it 240, or I'm actually making that 2/10 instead of 2/100, which is what I want. And again, if you're like, what are you talking about? We're going to do some more examples, so that'll make some more sense. All right, so let's hop down to the bottom here, and I do want to show you why this works. Not just because math is so interesting to me, because it is, that's part of it, but I really want you to understand what you're doing, okay? And not just memorizing, because now all of a sudden we're multiplying decimals instead of adding, and there's nothing about lining up the decimal points, right? With addition, we have to do that, and I'm hoping you understand it's because we're adding our place values together. With this, we're not lining anything up unless I change this to addition and said 9.8 plus 9.8. So I want to show you why you're doing what you're doing. All right, so in this problem here, 9.8 times 2. I'm sorry about the noise of the door upstairs. I don't know if you can hear it, but somebody is opening and closing the door over and over again up there. It's making a very loud noise. I'm sorry. Okay, so I'm going to set this up vertically, like standard algorithm. The larger number of digits I put on the top. So I'm asking you to do 9.8 times 2, right? And when I tell you to ignore the decimal point, and just multiply the digits, because that was our first little rule here, right? Ignore the digits and multiply the decimal point. What we're actually doing to ignore this, what could I do to put the decimal point at the end so it wasn't there? What could I multiply by? In order to get my decimal point to shift one place to the right, wouldn't I multiply by 10? So really what you're doing here is you're taking 9.8 times 10 to turn it into 98. Okay, so you multiply that by 10. And the 2 is staying the same. and you're just going to multiply your little digits. Now, you know how to do this. 8 times 2 is 16. 9 times 2 is 18 plus 1 is 19. Now, you know how you change this when you ignored the decimal point? By multiplying by 10. In order to get my value back to what it's supposed to be, because 9.8 times 2 isn't the same as 98.2, right? That's way different. So if you multiplied by 10 in order to solve this without the decimal point in it, guess what you can do to undo that? If you said divide by 10, you are correct. Now, if you're going to divide this by 10, wouldn't you need to shift the decimal point one place to the left? So it's currently at the end, right? You'd have to move it one place left. So it would be between the 9 and the 6, and that's how you would get your 19.6. So remember, we spent all that time learning how to multiply and divide by 10? This is why. So if I had 2 digits behind, like in this one, if you take 1.25 times 4, in order to ignore the decimal point, I would have to multiply this by 10 twice, right? 1, 2 by 10 squared. So I would be taking 125 times 4, and now I can go ahead and I can multiply normally, right? 5 times 4 is 20. 4 times 2 is 8 plus 2 is 10, and 4 times 1 plus 1 is 5. Now, in order to ignore the decimal point, we multiplied by 10 squared. In order to undo that and put the decimal point back in, because 125 times 4 isn't the same as 1 and 25 hundredths times 4, I have to do the opposite and divide by 10 squared. So if I divide by 10 squared, that means I'm going to move it 2 places back. And so in 500, if I want to move it 2 places back, it's at the end. I have to go back 2. And you get 5.00, or you could just say 5. Okay? So this is why it's working. When you ignore that decimal point and then put it back in at the end, 2 places to the right is the decimal point. That's equivalent to 2 tens. Okay? So let's do a couple examples. Turn your page. I don't think we're going to do all of these today, but I think we'll just do maybe the left column in that word problem. I'm pretty sure that's what I'm going to do in class today. All right, so right here I see that I'm multiplying a whole number by a decimal factor, and the little rule for this is to just multiply the digits ignoring the decimal point. So if this decimal point wasn't there, I'd have 0.7, which would just make it 7, right? So I'm just going to do 7 times 3, and 7 times 3 is 21, right? Now, this isn't really 7, it's 7 tenths, right? So I kind of multiplied this by 10 one time, or you can just say, okay, my decimal factor has 1 digit to the right of the decimal point. My decimal answer, or my answer needs to have 1 digit to the right of the decimal point. So my answer would be 2.1. Okay, jump down underneath to the letter C. If I ignore the decimal point, because that's my first step, if I just have 0.04, that's the same thing as 4, right? So really what I'm doing here is 4 times 2, right? And 4 times 2 is 8. Now, in my problem, my decimal factor has 2 digits to the right. So that means I need this to have a decimal 2 digits to the right. So right now I just have 8, right? The decimal's here. If I need 2 digits to the right, that means I need to hop back 2. There's my decimal, and what goes above that empty hop? A 0. So 0.08 is what I should have, or 8 hundredths. And you can put a 0 in the ones place as a placeholder. You don't have to. All right, letter E. If I ignore this decimal point, that's like saying 0.8, which is really 8. So I'm doing 8 times 6, which, yes, is 48. In my problem, my decimal factor has 1 digit to the right of the decimal point. That means in my answer, I need to move this 1 digit to the right. So my answer would be 4.8. All right, letter G. 2.04 times 3. If you ignore this decimal point, I now have 204. And I'm going to multiply that by 3. 4 times 3 is 12. 3 times 0 is 0 plus 1 is 1. And 3 times 2 is 6. My decimal factor has 2 digits to the right. My answer should be 2 digits to the right. So again, the decimal was at the end. I have to go back 2 because that's what this says. And 6.12, 6 and 12 hundredths. All right, for letter I, it says, Ellie wants to buy 24 angelfish. Each angelfish costs $2.35. Write and solve an equation to find the total cost of the angelfish. So she wants to buy 24 of them. They're $2.35 each. So that means she's going to pay $2.35 24 times. So the equation would be 2.35 times 24, right? So I notice this is a decimal value multiplied by a whole number. So I am going to rewrite this, and I'm going to ignore this decimal point. And if I ignore it, I would have 235 times the 24. So let's start with our 4. 4 times 5 is 20. 4 times 3 is 12, plus 2 is 14. 4 times 2 is 8, plus 1 is 9. I'm going to put my 0 here because this is really 20. 2 times 5 is 10. 2 times 3 is 6, plus 1 is 7. And 2 times 2 is 4. So 0, 4, oh, we're adding those, 16, 5. So right now, if you didn't put the decimal point in there, it looks like it costs Ellie $5,640. No, it was $2.35. In my problem, there are 2 digits to the right of the decimal point. That means in my answer, I want to move the decimal point, so there's 2 digits to the right. So I start it all the way at the end, and I move it back 2 times. And $56.40 makes a lot more sense, than $5,640. Why don't you go ahead and try this column on your own, and then come back and we'll check it. All right, welcome back. For this, I would do 4 times 8 is 32. There's 1 digit to the right, so that means I need to move this 1 digit to the right. So 3.2 should be your final answer. For letter D, 5 times 6 is 30. So that's ignoring the decimal point. I see there are 1, 2, 3 digits to the right of the decimal point, so I'm going to take it. It was here, right? 30, the decimal point's here. And I'm going to move it 1, 2, 3 places. I need to put a 0 in that 10th place. So you could say 0.030. This 0 right here doesn't do anything. So if this were a multiple choice test, you wouldn't see that 0 after it. You'd just see 0.03. If you did put the 0 after, it's not wrong because it's still equivalent. All right, F, I'm going to ignore this decimal point, and 9 times 7, or 7 times 9, is 63. There's 1, 2, 3 digits to the right of the decimal point, so I need to go 1, 2, 3. That means I do need a placeholder. So 63 thousandths is what I should have. And I'll put my 0 in the ones place. And in this one, 4 times 1.15, if I ignore the decimal point, I would have 115 times 4. So we ignore that decimal point and solve like normal. 5 times 4 is 20. 4 times 1 is 4, plus 2 is 6. 4 times 1 is 4. There are 2 digits to the right of the decimal point in the problem, so I need 2 digits to the right in my answer. So you could say 4.60. If this were a response on a multiple choice test, you wouldn't see 4.60. You would just see 4.6. That's because 6/10 and 60/100 are equivalent, right? If you think about them as fractions. All right, you're done with this lesson. Thank you for watching.